Welcome to today's monthly webinar. We do this the third Monday of every week. We call this the Data Science on AWS Meetup series. We have about 13 of these globally. Me and my co-host Antje Barth. We are also the co-authors of a book you might be familiar with here, which I'll show you. Here, looks like we're #1 bestseller today in business intelligence tools. Kind of fun. So this was launched about a month and a half ago. It's been flying off the shelves. Pretty excited about it. We would ask that you check it out. We've got a lot of bulk orders is what we found out, more so than most other books that have been coming out around now. So we imagine that's, you know, teams of whole like data science teams that are actually ordering this, managers ordering it for their folks, for their teammates. So the website datascienceonaws.com, you'll see links there. So this is datascienceonaws.com. You'll see links to the book and the workshops and the meetups and the GitHub and our YouTube channel. Oh, did I not share here? Okay, let me share this. Let me share. Okay, yeah, Greg or Alex, can you guys see my screen?
Yeah, we do.
Okay, great. So, and I just posted all the links into the chat there. So today's session is going to cover quite a lot of ground. We've got Greg Kokillo, tech manager on the Amazon.com side, which is always exciting. One of my favorite things about working for AWS is having access to the Amazon folks. They are pushing the limits of machine learning in, you know, all kinds of ways. I think in most cases we think of like Amazon and Netflix as like recommendation engines, and you know, that's one very sort of obvious use case because we're all users of these products and we see recommended products and we can imagine how these are being implemented. I've been purposely trying to find other use cases to open up our minds and like really understand what is Amazon doing beyond recommendations with machine learning and AI. And so Greg Kokillo is going to talk about that first. I think Greg's going to try to keep it to about 20 minutes. He's going to describe himself. He's going to talk about the types of work that he does. It's not a very slide heavy presentation. That's okay. We'll just be sort of asking him questions, and he's got quite a lot of knowledge, and he has some, you know, really good projects under his belt from Amazon and even before joining Amazon. The final talk today will be about RStudio with AWS AI Services and Sagemaker, and this is by Alex Lem. Alex is near Frankfurt, so it's towards the end of his day, and he is going to talk about how to use RStudio on Sagemaker, and also how to like integrate RStudio with the like AWS AI services, such as like recognition, which is for like images and video classification, and yeah, various other ones. So, okay, Greg, do you want to introduce yourself and just give, if you want to take over the screen and tell us what you're all about?
Sure. First of all, Chris, thank you for inviting me to this session, and great to be among Alex as well, and among you all following the presentation today. Name is Greg Kokillo. I am an industrial engineer by training. I do have a master's in engineering management, and my early career started in manufacturing before transferring to the tech side with Amazon. I'm currently a technology manager for the private brands division on the retail side, and I do provide compliance as a service to customers. Spend our time promoting trust, ensuring that products are being sold are safe while meeting the import and regulatory requirements wherever we do business through automated workflows. Now, what I'm responsible for exactly is the technology roadmap adoption. And I try to drive AI ML projects for my department. What I do is I lead these projects in collaboration with global teams of data scientists, software engineers, and most of my projects would fall under the innovation category because we've never seen this before around the private brands division. And there's a minimum of uncertainty that is embedded in AI and ML projects that I do enjoy. And the key is to plan carefully, gain alignment among the stakeholders. And the strategy that I typically use is prioritizing business use cases based on needs, efforts, and impact, followed by building and testing minimum viable products that can scale once tested and validated. So today, one of the use cases I wanted to talk about, and again, sorry for the low presentation case. This is a B2B multinational customer working in the chemical industry. As you know, per the regulatory requirement, chemical manufacturers, they must collect material safety data sheets from all their suppliers. And in turn, they must produce these MSDS containing elements from documents collected from their suppliers. And when they sell their chemicals to their customers, they must send these MSDS sheets to their own customers. So these documents are also received in different languages. So you can tell how complicated this can get if you have a product that pulls from multiple chemical components. To make one big chemical that you sell to a customer, you need to make sure that all of the ingredients are present in that final MSDS that you are supposed to send to your customer. So let me share my screen real quick to show you an example of what an MSDS looks like. Let's see here. Give me 1 sec. There you go. Let me know if you can see my screen. All right. So this is a quick example of what an MSDS looks like. In here you have identification of the product, the chemical product, and just to step back a little bit, an MSDS, this is a document, an official document that tells you how to manipulate, store this product. And also, in case of danger, say human contact, how to take care of yourself. In there are multiple things, whether you have identification of the chemical. Let me scroll down real quick here. The emergency phone number, who to call. You have the toxicity levels of this chemical. You have pictograms. You have different hazard statements, and also precautionary statements. As you can see here, this is making up for a good case for NLP, extracting many informations here and storing it in a database that you can then in turn pull to create your own safety data sheets. We'll go all the way down here. This is the instruction where you can have general advice for what to do when you have it contacting your eyes, on your skin, if you end up ingesting or inhaling. So going back to this use case, this particular customer was performing this work leveraging 60 employees in processing 100 to 150 documents daily for a yearly cost of $2.1 million. There are multiple bottlenecks, some due to data latency, lack of traceability of suppliers' documents to produce their own finished document for the finished goods. Therefore, the customer would most likely receive products without an MSDS, and that's exposing their own customers to regulatory fines from government entities when they're found non-compliant. Some other bottlenecks that they experienced were the lack of subject matter experts who were multilingual because these chemicals were coming from all over the world. For example, if you have to translate a document from German to English, it took time to find someone who who would qualify to properly translate these documents. And this is a good solution for machine learning because it can automate the revision of these documents through machine learning, natural language processing. When you think about how a human reviews a document, you can immediately realize that most of the work includes text detection, text translation, entity extraction, like identifying and validating the chemical names and company addresses. And part of that automation also includes computer vision for detection and extraction of pictograms, as you saw earlier in that MSDS example, and even signature for authentication of documents. So for that, we created a workflow, a web portal for the supplier to, as a solution, to submit MSDS sheets for raw materials at the time of shipping points. The submission of that document would trigger a series of Lambda functions that performs for different tasks. Because of confidentiality, I cannot share the correct architecture, but I can use an example for you to showcase what we created for the customer. And this started with an ingestion module where the incoming document would be put in a S3 bucket, and we would call a Lambda function. As you know, those are short pieces of code that run on serverless infrastructures that would separate from PDF and separate the images. And we would call the different modules from OCR to NLP module, where we're leveraging Amazon Textract, Amazon Comprehend to perform the different extractions and storage of these key data, and also serving that in an analytics module where we can make some analysis. Now, going a little bit more into these services, we're leveraging Amazon Web Services AI tools to perform different tasks, whether it's Textract to identify suppliers, validate chemicals, chemical descriptions, translate to convert German documents to English, comprehend to identify and measure safety risk in handling these raw materials, recognition to detect pictograms and validating their accuracies. The other task that we've done also is, again, storing in Redshift tables, and we leverage Amazon Elasticsearch services to create searchable document repositories. And as a result, the cost improved by 70%. We're able to reduce the headcount by 20 people for a total of $700,000 per year. We also saw a 90% plus reduction in manual errors and the 50% throughput improvement, which allows the customer to scale and onboard additional suppliers. The model's average performance, which is an aggregation of all the calls to these services, was around 96%. However, we focused on minimizing false negatives instead of false positives, simply because we wouldn't want to misidentify a dangerous chemical as not dangerous. We do also believe in the human in the loop system. Therefore, we also leverage Amazon Augmented AI to allow us to build a system where if a review did not cross a set of confidence level threshold, it would route it to a human reviewer to perform a final check. And that feedback was used to retrain the model as well. These AI A2I provides a continuous improvement environment for these models that we can leverage to improve as we go. A couple best practices in these sort of projects that could take months that I can share with you guys before I close is starting small. For example, selecting the supplier based in one country, and to test and validate your proof of concept. It's also important to fully explore the end-to-end business processes to make sure you understand how transactional data flows throughout these processes. And I believe that programs precede technology. You should focus on creating the program and its workflows to have a clear understanding of where technology needs to be injected. A couple don'ts that I can share is not trying to solve every issue, all issues at the same time. You should make sure that you start with one use case. Again, for example, starting with text extraction is a great start that you can start building on. One of the things that I also wish I learned earlier for this project is that the future plans for my customer. They were thinking about long-term integration with their legacy systems. So that would take technical efforts from their side and technical efforts from our side as well, which just increases the timeline on the project. But we were on par once we understood what their long-term vision was. As a key learning, we were able to readjust the timeline and work with them for the long term. One of the other vision that they have also is to build an in-house repository of labeled pictograms, as I showed earlier, specific to their products portfolios. So we were exploring custom computer vision solutions with Sagemaker. Again, the goal is to accelerate finished goods, the finished goods MSGS generation, and as well reduce duplication by identifying similarities between documents. And for that, we're thinking about leveraging a knowledge graph representation feature to make sure that we surface any missing components for this MSDS generation that allows users to take quick actions and close these gaps. With that, I will close. Hopefully, you have any questions for me. I can, sorry.
Yeah, Greg. We have a couple questions in the chat. First of all, what does MSDS stand for?
Material safety data sheets, sorry.
Okay, so material safety. The next question, data sheets. People like the way that you say sheeting.
I'm sorry?
Yeah, people like the way that you say the word sheet or sheeting.
Yeah, I can only blame that on my Haitian accent. So I speak French and Creole.
The next question, in a document with integrated text and images, do you split the doc and process each independently?
Yes, which this makes it easier because it allows the call to happen on different endpoints. So when you think about calling textract and calling comprehend or even recognition, we have to do these on separate workflows.
Okay, and how would you actually I guess rejoin that data later, right? There's captions that are associated with an image.
So these are captured on the back end. So we would leverage Amazon DynamoDB to store most of these captures and reconcile in the back end as is, and then reconstruct as a final product. Now, what we do is attach some metadata from this capture, and that allows us to understand where these extractions are coming from, and we use this metadata to produce the final product. And a lot of the secret here is to create a catalog for the lineage and ownership. So you want to have traceability of these extractions.
Gotcha. Okay, and looks like one last question, then we'll switch over to Alex here. So, Greg, how do you explain technical projects and details to non-technical audience and stakeholders? Any tips on that?
Yeah, that's a good question. For me is to clearly state what the problem is. I think most people can rely on a common problem that they're facing. If you're taking a look at the business process and you are able to identify the pain point, then what you need to focus on is clearly identify the solution, the problem, and then say what you will do as a solution in layman term that they can understand. And this is for the audience on the business side. On the back end, you know that who you will be working with is a team of technical audience who can understand a more complicated language. But even then, this technical audience will need to be able to understand the business terms. So being fluent in that business language is probably the best bridge to align both technical and non-technical. So focus on have a deep understanding of the business process and have a deep understanding of what the problem is in the clear way to communicate what the solution is in layman term. And that layman term needs to be understood by both technical and non-technical. And that's how you get alignment.
Awesome. All right, Greg. Yeah, thanks so much for joining us. I think today you're on PTO, right? Vacation.
Yeah,
so we appreciate you coming in.
Sounds good. It's my pleasure. Feel free to contact me, and I can talk to you more about this.
Okay, great. Alex, are you ready? Do you want to share your screen? And Alex has slides and demo and some goodies for us. So I really enjoy speaking with Alex. And Alex, yeah, take it away, buddy.
Yeah, thanks, Chris. I suppose you see my screen with the front slide, right?
Correct.
Can you?
Yep.
Okay. So, hey, hi everyone. Also from my side, also a big thank you to you, Chris, for having me in today's session. We will talk about how to leverage AWS AI services and Amazon SageMaker from RStudio. My name is Alex Lem, and I work as a so-called technical business development manager for artificial intelligence, like Chris and Greg, also here at AWS. And my personal focus, this is not reflected here on this slide, is actually machine learning for medical imaging with focus on radiology, pathology, and nuclear medicine. However, in today's talk, the clear focus is really R and RStudio. What we're going to cover are actually two major topics. So first of all, I'm going to show you how to leverage the AWS AI services from RStudio and also from Shiny applications. And secondly, I'm going to show you how to leverage Amazon SageMaker from RStudio. It's really important when we talk about RStudio in the context of this particular session today, that I'm actually referring to RStudio desktop. So to your locally installed IDE. So we're not covering RStudio in the cloud because we see that RStudio, or like our users or RStudio users, once they start their journey in the cloud, they usually start with their preferred environment. And this is most of the time their locally installed environment. So therefore, we will show you how to configure your local RStudio desktop environment in order to get started using machine learning in the cloud with AWS. Another important point is that all the demos you're going to see are actually part of 2 GitHub repos, which come with several R notebooks. So all the demos are fully reproducible, and I will share the links to the repos after today's session, so you can check out all the rest in more details. Because to be frank, I'm only going to scratch the surface here, and especially when it comes to Amazon SageMaker. You also need to tell me at the end of today's session if you would be interested in an in-depth follow-up session just covering the SageMaker from RStudio. All right. I just brought one slide to explain the context a little bit better, because this slide will also be used. We will use this slide also to navigate to today's session. Therefore, it's quite important just to go briefly over it. What you see in front of you is the so-called AWS machine learning stack. When we as AWS actually talk about machine learning or look at machine learning, for us, machine learning is is actually represented as a macro stack, which consists of 3 layers, with the AI services on top, Amazon SageMaker in the middle, and the machine learning frameworks and infrastructure at the bottom. And each one of those layers is actually addressing a different user persona. And in today's session, as you saw before, we're going to focus on the AI services and on Amazon SageMaker, not on the machine learning frameworks and infrastructure. However, it's important to know that Amazon SageMaker actually is based on the underlying machine learning framework and infrastructure you see here on this slide. And we start today's journey on top with the AI services. What are the AI services which are part of the machine learning stack? They are API-based services which come with pre-trained model, which are accessible behind the endpoints. The really charming aspect here is that you can easily add machine learning capabilities to your applications really, really quickly, whether it's an R application now in the R context, or also to your Shiny applications. And if you just focus on the bold headlines here in the first, like on the topmost layer, you see that we provide those AI services in 10 categories, starting with computer vision in the top left corner, followed by chatbots, also quite sophisticated services in the speech and text area, for instance. And if you take a look at the far right, we even provide dedicated AI services for 2 specific verticals, namely number 1, healthcare, and number 2, industrial, whereas industrial here stands for everything manufacturing related. The first question here I like to answer is how to access and leverage those AI services actually from R. And there are 2 preferred options you should choose from. The first option is that you use a combination of Boto3 and Reticulate. Boto3 is the low-level Python SDK, which we also provide and maintain as AWS. And Reticulate, for all of those who are here as like R domain users, you are most probably familiar with the package. It's an R interface to Python. The advantage of this combination is that you are actually using the officially supported SDK to Python SDK, namely Boto3. However, the main disadvantage is that you need to maintain a Conda environment at the site. So this is like an extra maintenance step for you. The second option is the Parse package. So the Parse package is actually the Boto3 equivalent for R. The major advantage of this package is that there is no Python dependency. So it's just like the R package you need to leverage. One of the disadvantages, and this is just like a smaller disadvantage in my personal opinion, Parse has not yet the full scope compared to Boto3. However, the team behind Parse, so it's an open source package led by David Critch in the US, is really, really quickly catching up. So from a practitioner perspective, my personal recommendation would be that you use option number 2 in order to get started using AI services, using the Parse package. If you find an unsupported API endpoint or a little bug, submit a GitHub issue in the Parse package. And as a fallback routine, like as a fallback, you can always use option number 1. So the combination between Reticulate and Boto3 until the next release of Parse. How do you actually configure your environment in order to get started? It's also quite straightforward, just 3 steps. First of all, you need to create dedicated IAM user via the AWS console, which comes with an access key ID and a secret access key. This is important because this gives you the option to actually programmatically access the AWS cloud by API function calls. Then, this is like an obvious point here, you need to install the Parse package. And then you need to configure 3 environment variables. So Parse gives you several options to actually leverage the credentials from step number 1. Here, I'm just highlighting the most convenient option from an R user perspective. So you save everything in your environment file. And besides the key ID and the access key secret, you also need to determine your AWS region, which you would like to use and where you will call the specific services you decide on. That's important because the underlying AWS region also defines and, of course, your billing in the end. And then you can start coding. And from a coding perspective, especially when it comes to the AI services, the meta schema is always the same. and highlighted here on the right-hand side. So you need to create a specific client for the AI services you like to leverage. Here in our case, we're actually creating a recognition client, and then the specific client object actually wraps the specific endpoints of that service via function calls, which you can access via the $ operator. So here in this little call, we are calling the detect text endpoint from the Amazon recognition service. And that's about the theory on how to use those services. And now we actually jump straight to the demo. And what I'm going to show you here is actually how to use Amazon Recognition, our computer vision service, to extract text from images. Amazon Recognition actually provides much more endpoints and capabilities besides extracting text from an image. However, we start with this simple example to give you an overview how to use this service. And the libraries I'm going to use is obviously the parse library, which is the SDK we need. And per is used for parsing the response, and readr, this we will show you later, to actually load local image data into memory. So let's get started here. And the image from which we would like to extract data, like the text from, is that one here. So it's a picture which shows a famous quote from Game of Thrones season 6, where the show, in my personal opinion, was at its peak. Before declining in season 7 and 8. And in order to, so sorry, I was in the wrong notebook. That's the one here. It's the second. And before we get started, actually using recognition, just like one more thing in how to use this service. Regardless of what kind of endpoint from recognition you would like to use, you have two kind of options to use it. So first of all, you can decide to either upload your data in question to an S3 bucket, and in the API function call, which you actually start locally, reference the respective bucket where recognition can find the data, or you send in the data directly as raw bytes. I'm going to show you both options here. The first thing we're going to do is, in case you haven't created an S3 bucket yet in your AWS environment in the cloud, this is what we're going to do here. For this, we also create an S3 client and then list all the available buckets. You see that in my personal AWS account, I have 17 S3 buckets. For this particular session today, I'm going to create a new bucket. So named Data Science Webinar July 19, Alex Lem. If you do this, make sure that your bucket name is really globally unique, because this is a prerequisite for creating S3 buckets. Next, I'm going to actually upload I will actually create the bucket here and list all the buckets. It's now 18 buckets, and here you see the bucket which we just created, and you see here just my local timestamp. So that worked well. And now we come to the picture we would like to actually use for extracting the text. So that's that one here. And in the first, we will use the first option, actually referencing the picture which we just uploaded in the API function call. For that, we first need to upload data to S3 by the put object call function here. So wait. Was my mistake. So that worked. Now we check if the object is really residing in the S3 bucket. Is, and now we're actually using recognition to extract the text from the image. And here you see, this is the meta schema I was talking about. We again create a recognition client. After that, we use the detect text function to extract the text from the image, referencing also the S3 bucket where our data resides. And below, we're using some per magic to pass the response which we get from this service. So let's execute this. And the region I'm using right now is actually the North Virginia region. So this function call was going across the Atlantic Ocean. Amazon Recognition was looking up the data in S3, and then she sent me the response, and here you see the respective response. And each single word which was detected is coming back as a separate vector entry. We can now also do the same by sending in data as raw bytes with actually omitting the S3 step, which is also an option. So the call looks quite similar, whereas here we are referencing the data which now resides in local memory on my laptop. Let's do this here. You see it's actually the same result. So this is how you would actually use Amazon Recognition or any kind of the AI services from R. Obviously, the power is also, when it comes to those AI services, the true power is to combine them or chain them together to cover different kind of tasks and different kind of use cases. And in order just to show you the art of the possible, it's not a sophisticated example. What we're going to do next is we're going to chain together 3 separate AI services. The first of all, Amazon Recognition for detecting text in an image. And for this, we're using the same kind of example we just showed you in the first demo. After that, we're going to pass the extracted text to Amazon Translate to translate the text into a different language. And then we're going to use Amazon Poly to create an Mp3 file. So Poly is a text-to-speech service, so that the service is actually that the user is actually able to download the respective audio file. And as you see, we are using the same image. For this, the same call as before. We just do some little bit more parsing here from the response instead of just relying on the vector. We are just putting together everything in a single string. This is what you see here. After that, we're going to pass on this particular string to Amazon Translate. And again, same kind of schema. We need to create the Translate client. Then as an input, we need to tell Translate what kind of text to translate. So this is like the text we stored in this variable. We need to specify the source language and the target language. And here we decide to translate everything in Spanish. So let's do this here. And here you see the response. So eso es lo que hago, bebo y sé cosas. And I can assure you this is the correct translation here. Next, what we're going to do is now we're going to use the translated text and send it to Poly to create an Mp3 file out of it. And it is straightforward, this function call as well. You need to provide the text you would like to convert into an Mp3 format. And then you need to decide on the voice ID. It shows Lupe here. Lupe is the female speaker for Spanish. So let's do this as well. Now let's store the Mp3 file, which came back from the service. And if I now navigate to my repo here, you can see that I just created and downloaded the Mp3 file. Unfortunately, because of the audio setup of this session, I'm not able to show you how it sounds. So it's up to you actually to run through the demo yourself. So this was just an example of chaining different kind of AI services together. And the really nice thing is you can easily add AI services also to your Shiny applications. In fact, what I did is it's more or less a copy paste of this process using those 3 services from this R notebook, which I put into another notebook. And for those of you who are familiar with Shiny, you see this is just like a Shiny document, which is the most simple Shiny application you can think of. If I go with you slowly through this through the code here, you see it's actually the same code as before. The only difference is, and that's the major difference, I put former API function calls to event reactive statements because I would like to make sure that the user actually hits a button before the API call is sent to Recognition and other services. So here you see the event reactive statement for the Recognition client, followed by Translate, followed by Poly, and then the second major difference compared to the former notebook is, of course, that I also provided a download handler so that you can download the file from the server. So let's run this document locally, how it looks like. So again, pretty straightforward here, nothing sophisticated. I even need to copy paste. But as you see, when I hit as a user translate text button here, it's actually also going to the AWS cloud from my laptop here, and then I convert everything to an MP3 file, which I then can download from the server, right? And obviously, we're not limited to use it locally. For those of you, and this is also part of the repo one exercise. I also deployed it to shinyapps.io, and here it's the same thing, of course. Here it's deployed to shinyapps.io, which is a service from RStudio, and the cool thing is that the first 5 apps you deploy there are free, and when you now execute everything we saw before, so I'm just clicking here on the first button. What happens here is actually it's a cloud-to-cloud communication, right? So because here I'm accessing my Shiny app and in my Shiny Apps IO user account, which then communicates with the Amazon Recognition, Translate, and Poly services in the North Virginia region in the US. And that is actually everything I wanted to show you when it comes to using the AWS AI services using the PaaS package. Coming to the next topic from today's call, and this is actually using Amazon SageMaker from RStudio, again from your local RStudio environment. What is Amazon SageMaker? So Amazon SageMaker is a fully managed machine learning service, which is modular, which really covers the entire data science or machine learning process end to end. So you see components for data labeling, you see components for data pre-processing and data exploration, you see dedicated components for machine learning training and tuning in the cloud, and several deployment options. Each one of those components is accessible via a single unified IDE, which we also provide, which is called Sagemaker Studio IDE. It's actually based on Jupyter Labs. However, similar to the AI services, since those different components are accessible via APIs, you can even pick and choose dedicated components you like to integrate in your current workflows, even in your current local workflows, so that you actually get started using just different parts in the cloud. And this is what we're going to do today. In more precisely, we're going to have a look at just the SageMaker training component. Similar to what we talked about for the PaaS package, the different options here on this slide on how to get started and how to configure your environment. So the preferred option, and it's actually the only valid option right now, in my personal opinion, is to use a combination of the Sagemaker Python Sdk. So this is like the high-level Python SDK for SageMaker in combination with Reticulate. The reason for this is there is not yet a high-level native R library available to access SageMaker in the cloud. However, there's a really promising project, which you can see on GitHub from Defan Jones. He's actually rebuilding the Python SDK using R6 classes and the PaaS package. It's early stage, but once this package is up and running, then this will be the preferred option. As of today, this is my recommendation how to exit it locally. In order to configure your environment, you also need to run through several steps. But in total, I measured the time yesterday. It's less than 10 minutes what you need here in order to set up your local environment. So first of all, you need to, again, create an IAM user. You can use the same IAM user as in the AI services example. However, this time you need to store the AWS credentials not in an R environment file, but in 2 specific files in your user account, which you see here in point number 2. Then you need to make sure to store and create a dedicated Amazon SageMaker role, and you need to save the SageMaker role ID as an R environment file. Last but not least, but this is also just 3 lines of code, you need to create a dedicated Conda environment, which we will leverage later. And once you are done with this, you can actually get started. And this is what we do as well here. And the data, what we're going to analyze, and again, it's not so much about the data science project here, but just about how the different functionalities, to use different functionalities in order to use SageMaker training jobs in the cloud. So I'm just going briefly over this. What we're going to leverage here is, or use is a data set, which was also highlighted and features in a Tidy Tuesday article from Julia Silch. She's also with RStudio. And this particular data set is the hotel bookings data, where which we will use to actually create a machine learning model to predict if certain stays included children, where those stays that didn't. And we will use all the other characteristics and variables in this data set in order to make our predictions. So I already run through the notebook before, so I'm just going briefly through the code before actually executing some critical code snippets together with you. So here we're going to load all the necessary packages, which I'm going to use in this notebook. However, we're just going through 50% of this notebook until the model training. So the most important thing for us here is using the reticular package. After that, I actually downloaded the data from the internet, and you see the data. It consists of 50,000 observations with 23 variables. When we take a look at the distribution from the dependent variable, we see that it's actually highly unbalanced, so that we have much more observations which did not include any children in the hotel visit compared to those who didn't. When it comes to the pre-processing steps, it's also pretty straightforward. So the main thing I did here is I was actually inflating the feature space by adding specific binary variables for each of specific holidays you see here. And then I also converted all of the categorical variables also in one or more binary variables. And the main reason I did this is because I'm going to use XGBoost later for the model training in the cloud. And one of the prerequisites for using XGBoost is that all data is actually passed on as numeric data. And here you see the result of my feature inflation. So from 23 variables in total, also including the dependent variable, we are now at 242. Then I split the data into a training, test, and validation and test set. I made sure to check out if the stratified random sampling, which I used via the initial split function, actually worked correctly, and it did. So when we take a look at the training set, we see it's almost 92% to 8%. Same for the validation data set, and the same for the test data set. Then I actually uploaded, actually saved different 3 data sets as local CSV files. And now let's jump here to this. Then I'm used, was the first part where I actually used the configured Conda environment, the SageMaker environment, for one particular reason. In order, we uploaded the data via the SageMaker object here to the S3 bucket. And for this, we created an S3 uploader and uploaded the data to S3. Until this point, there's nothing special compared to your local setup when you would go through the machine learning process yourself. Here, you would actually raise the first question and ask me, why did we do this? Why did we upload the data to S3? And for this, to answer this question, we need to go through some theory together, how training jobs in SageMaker, if you launch them from your local environment, actually work. Then it will become clear. You start any kind of SageMaker training job locally by creating an estimator object and then by calling the .fit function on the estimator object. When you do this and you call the .fit function, SageMaker will do the following. It will first create a short-lived training cluster, which will only be online as long as the training job is online. So after that, SageMaker will shut down the training cluster. Once the training cluster is up and running, SageMaker will pull in your training and validation set. So in our case, we use both training and validation, as well as the training image, which resides in the Elastic Container registry. So the training image, which will be pulled into the short-lived training cluster, is a Docker image, and it comes with the respective algorithm. So the estimator.fit function, which you use to call SageMaker, consists of the information. So the parameters actually are three major parameters. So you reference the S3 data, which you uploaded to S3, which we already did. Then you reference the respective training image you like to use. In our case, you will see it in a second, we're going to use XGBoost. And then you're also specifying the underlying infrastructure you like to use for the short-lived training cluster. Then your training will start. Once your training is finished and your model is your model was trained, SageMaker will put the model into an S3 bucket. Here in this example, I'm using another S3 bucket, however, just for illustration purposes, but it can be the same bucket as the one where the data resides, of course. And then it will shut down the training cluster. We are back at the beginning. In order to digest this information a little bit more, so let me just take one step back and show you this state here. And this picture now actually also tells you why the cloud is so powerful and how you can leverage the cloud for your machine learning projects. Because of course, you're not limited to launch a single SageMaker training job from your local environment, but several ones in parallel. So you cannot just choose a single algorithm, you can choose several algorithms, or if you use a single algorithm, you can try different hyperparameter settings, and all of those training jobs will be executed in parallel. This will accelerate your research, first of all, and secondly, it also gives you the option, for instance, to try out deep learning algorithms or any kind of algorithms which rely on GPU-based infrastructure, which perhaps is not available to you on your local workstation, right? This is like actually summarizing the true power of the cloud when it comes to training and how you can actually leverage a SageMaker, the SageMaker training component already today as part of your workflow locally. And this is what we're going to do next. So we have uploaded the data, and what we're going to do is we're now creating an estimator object and start a training job with our data. It's also pretty straightforward. And here you see that in the estimator object, I'm going to reference the respective container I would like to use. Here it's the XGBoost container with XGBoost version 1.3.1, specifying the underlying infrastructure for my training cluster. After that, I'm using the set underscore hyperparameters function to define the hyperparameters. Here it's just static hyperparameters, so no tuning will be involved in my training job. After that, I need to define the where the S3 data resides. And then I'm ready to go, and I hit the fit function. Now we actually started from my locally configured RStudio environment here, a training job in the cloud in North Virginia. I can check here also the training status, so it's in progress. If I now navigate with you to, I need to find the window. The console you see here, I'm actually logged into North Virginia. When I check out training jobs, you should see one training job. Okay, timeout. We'll be there in a second. So again, we are going to Amazon SageMaker, and underneath the training job section, we will see one training job which we just started. This is in progress, and we see that we are in the North Virginia region. So this is actually right now happening on the US soil. And shortly before this session, I actually created another training job, because you see the entire training job is about 4 minutes. when we go into the details, you see that even though the entire training job was 4 minutes, the net training time was just 57 seconds. And it's important to highlight that you as a customer, you're not being billed for the ramp up time and the shutdown time of the training cluster, but just for the net training time. This is the reason why the billable time is equal to the training time. So even though the entire training job was 4 minutes, you're always being billed for the net training time. Again, this just like shows you how to integrate just Sagemaker training as part of your local workflow. What we didn't cover, and which is still, but part of the self-paced workshops on GitHub, is also notebooks on how to actually leverage Sagemaker for tuning jobs, how to deploy your models to Sagemaker in the cloud using different options, and also how to use a different kind of marketplace algorithms. And if you're interested to dive a little bit deeper, those are the training jobs I was referring to, and just need to actually go to the chat here and find it so that I can share the links with you. However, I'm not seeing the chat window. So, here we are. And I'm still not seeing the chat window. Chris, do you know where the chat window is when I'm a presenter?
Yeah, it'll be down right next to the share screen button that you used on that floating toolbar. And it'll be, if you hit for the word chat.
Let me just stop sharing here first. Now I see the chat. That's strange. Okay.
Oh, got it. Yeah.
So let me just share it here to all attendees. So if you would like to dive deeper, have a look yourself.
Yeah, that was one of the questions. Okay, great. Those are all the links right there. Beautiful. I'll paste those in the Meetup as well too. A couple people were a little bit confused about how to actually connect RStudio to Sagemaker. Can you just give a quick recap of how you did that, Alex?
Yeah, so I just need to go through the respective slide and go into presentation mode. Basically,
you create a user through IAM that has credentials, and then inside of RStudio, you provide those credentials.
So this is like the process. So you first need to create an IAM user to make sure that this particular user, like your admin user, for instance, really has an access key ID and a secret access key. Then, because you're going to use this user locally to access the Sagemaker components, right, in the cloud, you need to make sure to store them locally, and you're storing those in 2 different files. So under your home environment, like in your home directory, you need to create a .aws directory, and there you need to create a credentials file where you store the key ID and the access key. And then you also need to create a config file where you specify the region. This is step number 2. After that, because this is like the 3 things you need for step number 2. Then you need an additional environment variable, which gives Sagemaker the option to actually access, for instance, S3. And for this, you always need to make sure to provide the respective role RRN together with several function calls. And in order to integrate this RN user as part of your function calls, it's recommended that you store the information as an R environment file. This is actually also step number 3, and then you need to create a conda environment. And once you are through those 4 steps, you're good to go. And then it's actually just a matter of the only thing, once the setup is complete, you are just then using the reticulate package as part of your R workflow when we go into the script. And then you just load the respective Sagemaker environment and you can leverage the full power of the cloud also locally. And this is what I'm doing here. So once your setup is complete, you just need to use those 3 lines of code in order to get started using Sagemaker.
So ultimately, the REST APIs for AWS are being invoked, right?
Yes.
And that is commonly called Bodo 3, which was the name of the library that someone or a group had created many years ago, and then AWS rolled in that library to be the official Python library. Someone asked, is R more or less scalable than Python for large data sets?
Well, I mean, this is like R and Python specific, right? This has nothing to do with SageMaker, because for the scaling option, when using SageMaker training jobs together with R, we're using actually SageMaker, the SageMaker training cluster in order to scale. So how you actually call from where you actually make the call either from R or from Python to the SageMaker training component to start your training in the cloud actually doesn't matter. The thing is different between Python and R when it comes to locally to training jobs which you execute locally.
Right. Yeah, and SageMaker will handle distributing data. If you have, let's say, 6 files and 3 nodes, it'll put 2 data files on each node. It'll handle, the data sharding, and then it's up to your R code or your Python code to then operate on those files. And then, yeah, okay, great. There were just, a couple kind of guidance questions on how would you choose R or Python. My initial answer was really it's a preference, it's a team preference, it's a skill level, it's familiarity with the visualization libraries, the math libraries. Any other advice, Alex?
No, I mean, you basically answered it. And the core intention of this webinar was actually showing the R community that they can actually also quite easily leverage machine learning in the cloud using AWS services, because when you take a look at the official documentation, it's most of the time it's just Python based. However, I think for R users, for any kind of R users, beginner or advanced, they can really add the AWS machine learning stack to their toolbox using different kind of configurations. And this is just a plus in order to accelerate research, in my opinion.
Sure. Yeah, and having come from Databricks, when I was there, we had lots and lots of R users, and so the Databricks product supports R, Python, Scala, Java. So R is certainly not dead. It's being used by many thousands of folks, and so really great to see a nice clean example of how to use R with SageMaker. Yeah, thanks so much, Alex.
Yeah, thanks for having me.
Okay, and we're past the top of the hour, so do need to close it out here. Yeah, Greg Kokillo, thanks so much for your time as well too. And we'll see you all next month. I'll post the video here in about probably 30 minutes to an hour. Just depends on how long it takes to
Thank you, Chris.
play the video.
Thanks,
you, Greg.
Great presentation.
All right. Yeah, bye everyone. Thanks.